So in this question here, you have got A, B, C, D, okay, is in the horizontal plane, right? That stage there. And A is directly above B, and AB is a vertical line. Then you've got AB equal to H, BC equal to CD, they are both equal to X, and BAD is alpha, BCD is equal to theta. Okay. Please don't be scared because you saw the diagram. Okay? Don't be scared because you saw the diagram. As I told you on Monday, or yesterday, this question requires knowledge of trig ratios, area sine and cosine rule, compounded double angles. You might need your knowledge of reduction formula. That's all. That's all. And obviously your knowledge of angle of inclination, your knowledge of triangles and so on is required. So the first question says, show that BD squared is equal to 2x squared times 1 minus cos theta. Whenever you see a question like this, as long as you have got cos, like in this case here, as long as you see cos, when you are doing a question on 2D and 3D, there are only two concepts that you're supposed to use. Trig ratios, if it's part of a right angle triangle, or if it's not right angle triangle, cosine. So you should not get nervous because you saw that diagram and you saw those equations. Right? So A, just gonna use my knowledge of cosine. Okay? So BD, if this is BD, it's part of triangle BCD, and BCD is not a right angle triangle. Therefore, I have to use the cosine rule. Okay? So if I use my cosine rule and I calculate BD, remember, so it will be BD squared is equal to CD squared plus BC squared minus 2 times CD times BC times cosine of this angle here, which is theta. It's not difficult. You make it difficult on your own. Okay? Then you substitute. So BD squared is equal to CD is x, so this becomes x squared. BC is x, that becomes x squared. So we have 2 times x times cos theta. Then you simplify this, that BD squared is equal to x squared plus x squared, that will give you 2x squared minus 2x squared cosine of theta. You must also look at the equation that you are supposed to show, so that it guides you. Okay? So I've got this 2x squared, I've got that minus 2x squared and the cos theta, so I'm on track. The next thing is just to factorize. So this becomes BD squared is equal to 2x squared times 1 minus cos theta. Then you are done. Unfortunately, it's a proof, so you cannot make a plan. Okay? You can't make a plan here. Okay? So that's what you were supposed to do. Before you write your next paper 2, make sure you remember that you see the question on 2D and 3D. It will always be there. There is no way you can escape it. After the 2 graphs, last question on 3D problems. Trig ratios from grade 10, the reduction formula, the compound angles, double angle, area sine and cosine rule. That's it. Okay. Now, once you finish that, now you need to know that in most of these type of questions here, the first one you need to do the second one. You see here it says hence. Even if they don't say hence, you should know that what I just did at the beginning, I need that to do the next question. There is a connection with these questions. Okay? So the next question now, it looks scary because there's a square root and that tan alpha, but it's not that scary. So since we are told that ABCD is in the horizontal plane and AB is the vertical line, it means this AB is perpendicular to BD. It's also perpendicular to BC. Therefore, ABD is a right angle triangle, ABC is a right angle triangle. So you can use trig ratios. Remember, trig ratios are only used when you have a right angled triangle. Remember that. You only use trig ratios if you have a right angled triangle. Yes. This angle here, ABD, it's a right angled triangle because AB is a vertical line. It's written here. Therefore, triangle ABD is a right angle triangle. Also, that angle will be 90 because AB is perpendicular to BC. This is more like it's in 3D. You have to visualize it as well. Okay, so I think it's easy now. So let me carry on. Right, the same diagram. So just add here. This is 90 at 90. So what I'm gonna do, since I've got this tan alpha, the only way that you can create the tan alpha is by using trig ratios. I hope you are aware of that. At this stage, because we don't have a tan rule. Right? We don't have that. Okay, our reduction formula, they are for all of them, but sine, cos, and tan. Right? But for this question here, one way that you can introduce the tan alpha is by using trig ratios. Okay? So this angle here is opposite BD, so that becomes the opposite side, then AD is going to be the hypotenuse. Alright? And obviously AB is going to be the adjacent side. And AB is equal to H, that's where this H comes in. Okay? The H is going to be an adjacent side. Okay? So in triangle, I'm going to use, okay, let me make a decision here. I might need to use ABC. Okay? Yeah, it's better to use ABC because, okay, in this case, okay, BD, I've got it from there. Yeah, so I can carry on by using ABD. Okay, so I can carry on with using ABD because this 1 minus cos theta I got it by, sorry, from part A of the question. So I have to carry on and use triangle ABD. So in triangle ABD, right, if I use trig ratios, okay, my opposite side is going to be BD, obviously, so it will be tan alpha is equal to the opposite side, which is going to be BD over the adjacent side, which is H. Okay, but BD squared is equal to 2x squared times 1 minus cos theta from the first question. Right? Then you find the square root, so you end up getting BD equal to the square root of 2x squared times 1 minus cos theta. And I hope that you remember you said this x squared here is a perfect square. So we can find its square root and then take the square root outside. So you should know that. So you can do it as x times 2 times 1 minus cosine of theta. Okay? Right? So that's how you come up with that square root of 2 times 1 minus cos theta.
That's in the question you don't see whether the x is like a number, it's like a
part of the square root, sir.
so it's response to square root 4 because like x
We're talking about being, for it being outside the square root sign. It comes from a knowledge of sets.
so
Yes, here, you see here, we've got the x square.
so no yeah and the question
Yes, I'm telling you where it comes from. You, by now, you should know that if I give you something like this, say the square root of 3x squared, like that. But after to simplify it.
so can you write 3 root 6
Why are you bringing in the
No, sir, I want to show you something.
cube root of what?
Isn't cube root has 3 at the top?
Yeah, if it was a cube root, then you could have something like this. If you have got something like this, means you can take the x outside.
So you see what the x position?
Yeah.
It's like that.
No,
Where the 3 was.
the x is multiplying square root of 2 times 1 minus cos theta. Okay? So this is where it comes from. Once you have got that, it's very simple. You plug the thing there. And then you cross multiply. So let's carry on. Let's carry on the next page. So from there, we are going to end up having tan alpha is equal to x times the square root of 2 times 1 minus cos theta. This is all over what? See, that is easy. And then you swap those two.
Yeah.
You don't need to do any cross multiplication. Then you say, therefore, h is equal to x times 2 times 1 minus cos theta. That's all over what? Tan alpha.
Where's the brackets there?
Okay? All right?
You see?
Okay, and then you're done.
Yes, sir.
So these questions, if you perceive them as difficult, they will become difficult. Okay? But they are not as difficult as you might think. And if you hang around with people who say they are difficult, they will become
It's a much pretty.
all right. Okay. Right, the last question, it's always an easy question. It says calculate the value of h, pay attention. If x is 100, theta is 60, alpha is 40. That's very easy now. If you are writing an examination, you struggle to do part A, part B. At least, do part C.
Yeah, I agree.
So,
Yeah.
You can't get a 0 for the whole for the whole question.
so, you just
All right. Okay, so let's substitute x, theta, and alpha. Right, so for part C, right, h is equal to x times 2 times 1 minus cosine of theta all over tan alpha. Right, so the h is going to be equal to x, it's 100, okay, let's write it down, times 2 times 1 minus cos 60 all over tan 40. When you use your calculator. Okay. You must round up to 2 decimal places to find out.
What's that?
You must round up to 2 decimal places. And be very careful.
Besides that thingy.
What?
What do you calculate?
You're calculating h.
So, like, oh, it's not 119, 1.8.
119, 1.8. This should be meters. Now let me verify that.
Is it?
No,
Degrees.
they didn't specify what units, so it will be units. Okay, because x is not specified as in what unit it's going to be. Okay, so just write 119,18. Are you all getting that?
Yes.
Nice. So that's it.